So today is video 2 of day 3 for Unit 8, Polynomials and Rationals, and we are covering greatest common factor, which we like to call GCF. So first let's talk about what it is. The first thing, it's the largest number and or letter that is a factor, meaning it's a multiple of 2 or more terms. So if you have multiple terms, the GCF needs to be able to go into all of those terms. So we've got a couple steps. So the first step is to find all the factors of the smallest term. Let's think smarter, not harder. You could find all of the factors of all of the numbers, but you really just need to look at the smallest of the numbers that are given to you. And we're going to write them in order of descending. So the biggest numbers are going to be at the top, and the smallest numbers are going to be on bottom. Then, starting with the largest of the factors, you're going to check to see which will work in the remaining other numbers. Again, this will make sense when we look at a couple of the examples on the inside. So the first one I have is 20 and 36. I'm trying to find the GCF of those two. First question to ask yourself, which is the smaller number, 20 or 36? 20 is the smaller number. So I find all of the numbers that multiply together to give me 20. Well, that's 20, which I'm going to put at the top, and 1 at the bottom, because 20 times 1 gives me 20. And then 2 will also go into 20, so 2 and 10. 3 won't go into 20, 4 will go into 20, so 4 and 5, and then there's no number in between. So those are the numbers that I am looking at. So then I need to see which of those numbers are factors of 36. So starting at the top, I start with 20. I use my calculator. 36 divided by 20 isn't nice. It's not pretty. It gives me a decimal. So that's not it. I go to 10. 36 divided by 10. That's not pretty. I go to 5. That's not pretty. Now, do you have to use your calculator? No. If you know that 36 divided by 10 is not going to be pretty, you can just X it out. 36 divided by 4 is pretty. So my GCF between 20 and 36 is 4. Now I've got three numbers, 24, 42, and 36. The smallest number is 24. So I'm going to start with my factors. Largest one's on top. So 24 and 1. 2 will go into 24. So that's 2 and 12. 3 will go into 24. That is 3 and 8. 4 will go into 24, so that's 4 and 6. So this is a lot like when we did the factor sum chart when we were doing factoring. But instead of writing them side by side, we're going to write them in descending order. All right, and the only numbers between 4 and 6 are 5, which isn't going to go into 24, and 7, which we actually technically already passed. So the only numbers in between 6 and 4 is 5. It won't go in. So now I need to see which will work in the other two. Will 24 go into 42? It will not. Will 12 go into 42? It will not. Will 8 go into 42? It will not. Will 6 go into 42? It will. And then 6 also goes into 36. So that is my GCF. I have no reason to check 24, 12, and 8 into 36. It didn't work for 42. So it wouldn't be the GCF because the GCF has to work in all three terms. This next one, 24 and 90. Again, I just did all the numbers for 24. So I'm just going to rewrite them again over here and see which of those works in 90. 90 divided by 24 is not going to be pretty. 90 divided by 12, not pretty. 90 divided by 8, I don't think is pretty. Nope. 90 divided by 6, that one's pretty. So my GCF between those two is also 6. 56, 42, and 91. My smallest number is 42. So I'm going to find all of the factors of 42. So 42 and 1. If you're unsure, you can always use your calculator. 42 divided by 2, yes, so that's 2 and 21. 42 divided by 3, that's 3, and then 14 is going at the top. 42 divided by 4 doesn't work. 5 won't work because it doesn't end in 0 to 5. 6, 6, and 7. There is no number that's going to happen between 6 and 7, so I'm done. Then I'm going to see which of those factors work in the other two. So I'm going to go to the 56 one. 56 divided by 42 is not pretty. 56 divided by 21, also not pretty. 56 divided by 14, that one's okay. So now I'm going to go check with 91. It's not pretty. So 14 is not the GCF. It has to work in all of them. Just because it works in one of them does not guarantee it's going to work in the other one. 14 worked for 42 and 56, but it does not work for 91. So we're going to keep going. Going to 7. 7 works for 46. And 7 works for 91. So my GCF on that one is 7. 2 more to go. 16 is my smallest number. So 16 is 1 and 16. So 16 and 1. 2 and 8. 3 is a no. 4 is the other one, and it's just 4 and 4. So seeing which of those work. 16 doesn't work. 8 does work, and 8 will go into 80 because 8 times 10 is 80. So 8 is my GCF there. Last one for GCF of just numbers. I haven't looked at 48 yet. 48 is the number that I need to see. So 48, that is 48 and 1. That is 2 and 24. 3 will not, 3 and 16, 4 and 12, 5 will not go into 48, 6 will go into 48, that is 6 and 8, and the only number that's in between there is 7, and 7 won't work. So see which of those works for 64. 48 doesn't, 24 doesn't, 16, maybe 16 does work. So your GCF on that one is 16. All right, so now we're going to talk about how do you find GCF with variables, because we're going to be doing these with a mix of numbers and variables. So let's talk about if we just have two terms. If I have x to the third and I have x squared, that means I have 3 x's in my first term and 2 x's in my second term. So how many do both of them max have? Well, they both have a max of 2. The first one has 2, the second one has 2, so my GCF is x squared. Between x and x squared, first group only has 1x, second group has 2x, so what is the max amount of groups I have in both terms, or the max amount of x's I have in both terms? I have 1x in both of those terms, so the GCF there is just x. So, looking at my choices, the first one, my GCF was x squared. The second one, my GCF was just x. So if you have variables, where can you find your GCF? And the answer is the one with the smallest exponent. My smallest exponent between those first examples was x squared. My smallest exponent between the other two was just x. Now, if you have a situation where you have multiple letters, the letters have to be in all terms. You have to have this many x's and this many y's in all terms to call it a GCF. So now, how do we find a GCF if we have a mix of letters and numbers? We've got 5 steps. You're going to first find the GCF of the number part. You're going to find the GCF of the variable part. You're going to divide by the GCF. You're going to put the GCF part outside the parentheses. And the leftovers, what happens when you divide, those are going to go inside the parenthesis. And what's great about this is you can always go back and check to see if you are right. You can always go back and distributive property it back and make sure that you get that piece up top. Because really the GCF is the inverse of distributive property. So I have 2n minus 4. I only have one term with a letter, so I don't have to worry about finding the GCF of the letter. My smallest number is 2. Again, when you find the GCF of numbers, you're looking at the smallest number. My smallest number is 2. The only thing that goes into 2 is 2 and 1. So will 2 go into 4? And the answer is yes. So my GCF is 2. So I'm going to divide both terms by 2. My GCF goes on the outside. 2n divided by 2 is n, and then 4 divided by 2 is 2, and then we keep the sign that is there. Again, if I were to distributive property that back, I would get 2n minus 4. The next one, 8 and 6x to the fourth. Only one of them has a letter, so I don't have to find the GCF of the letter, but my smallest number is 6. So I'm going to do my little GCF with the 6. So the things that make 6 are 6 and 1, 3 and 2. Starting at the top, 6 won't go into 8, 3 won't go into 8, 2 will. So 2 is my GCF. Divide both terms by 2. 8 divided by 2 is 4. 6x to the fourth divided by 2 is 3x to the fourth. I'm not touching the letters. There's nothing I'm dividing by with letters, so I don't have to worry about the letters because only one term had a letter. All right, the next one, 5r plus 4r to the fourth. So my smallest number is 4, so I'm going to drew all the factors of 4. 4 is 4, 2, and 1. 4 won't go into 5. 2 won't go into 5. So my GCF number-wise is 1. And because I do have letters in both, my smallest exponent is just r, or r to the first. So I'm going to divide both of these terms by 1r or r. GCFs go on the outside, and 5r divided by r, or 1r, is just 5. My r's are going to cancel, or you can think about as subtracting the exponents, because that's what you're doing when you're dividing by terms. You are subtracting the exponents. R1 minus R1 cancels out, so you just have 5. And then 4r divided by r is 4r to the third, again, because you are subtracting exponents. 4 minus 1 is 3, so that's 4r to the third. 4x to the fourth plus 8x cubed minus 12x. My smallest exponent is x. My smallest number is 4. So I'm going to find all the factors of 4, which is just 4, 2, and 1, and then go through. Will 4 go into 4? Of course. Will 4 go into 8? Yes. Will 4 go into 12? Yes. So I'm going to divide all three terms by 4x. And my GCF is going to go on the outside of the parentheses. Now, when I divide this, 4x to the fourth divided by 4x. 4 divided by 4, those cancel. X to the fourth divided by x is x to the third. Now, you can put a 1 there. You don't have to. 8x cubed divided by 4x is 8 divided by 4 is 2. X to the third divided by x is x squared. And then 12x divided by 4x is 3. Again, you could distributive property that back and make sure that you get that top piece back. This one's a little on the tricky side because it's the first time that my smallest exponent is not 1. The other thing I notice about this is they both have negatives. So we're also going to take out a negative. You can only do that if all things have negatives, and all things here have negatives. So my smallest exponent is 2. Again, I've got a negative, and my smallest number is 9. So the factors of 9 are 9, 3, and 1. 9 will not go into 12, but 3 will. So I'm going to divide all terms by negative 3m squared. And I'm actually not going to write this one because you don't have to, but it's helpful if you do. So negative 9m to the third divided by negative 3m squared. Negative 9 divided by negative 3 is 3, and m cubed divided by m squared is just m. 3 minus 2 is 1. Negative 12m squared divided by negative 3m squared is going to give you plus 4. The m squareds are going to cancel. So this one is negative 3m squared times 3m plus 4. This last one, I have an x in both terms. My smallest exponent is x. My smallest number is 8. So 8 is 1 and 8, 2 and 4. What of those go into 18? 8 won't, 4 won't, but 2 will. So 2x is my GCF. I'm going to divide both terms by 2x, which is going to give me 4x squared, and then minus 9. And that is my GCF, factoring it out. But think about, what did we just learn in the last video? Two terms, minus in between, check to see if they are perfect squares. 4 is a perfect square, x squared is a perfect square, 9 is a perfect square, so that one can keep going. So make your two parentheses with your GCF out in front. Take the square root of 4x squared, which is 2x. Take the square root of 9, which is 3. You make 1 plus and 1 minus. And that is that one completely factored out. So this was the end of day 3. We've talked about DOS, difference of squares, and we've also talked about GCF, greatest common factor. So good luck.